Yeah, so today we gonna discuss about the performance tuning tips in Postgres, and this is the module objective which we are going to cover. What are the main parameters that we are going to tune, and based on which tools or based on which parameters that we have to define the main parameters, especially the memory parameters. As we know, Postgres cluster mainly behaves based on the parameters which we have defined. So parameters are very important, which we have to define when we build a cluster. So basically, whenever we build any new cluster, we should not directly hand over to any application team. First, we need to define proper standards, like the passwords and parameters. Especially, we have pgtune tool, which we are going to give some of the inputs like system resources to it, and it gives the recommended parameters, right? This we discussed in parameter file management. Anyhow, that is the initial parameters that we need to configure with the help of pgtune. Later, based on some of the benchmark tests, or we have to change this memory parameters, right? So we'll see what is the benchmark test, what are the tools available for benchmark test. Okay, so and based on that benchmark results, how we can define the memory parameters. Okay, that is very important. And obviously, after you define your parameters, we have to configure backups. We have to configure logging. We have to configure, any tuning packs. Okay, like Postgres is an open source. Okay, we don't have any performance tuning packs. Okay, so we have to go with again some extensions. So we have some extension called PG profile. Similarly, like AWR report, we can generate report, okay, stats report of the database, not a specific database. It's for entire cluster using this PG profile extension. Okay, so we can just whatever database you need, you can just create that extension, and we can generate this report. And you can just generate every 30 minutes or every 1 hour based on your requirement. We can configure similarly like AWR report as well. Okay, and the database design as well. So whether a table need a partition, or a table has to go with table space, index table space, or table space, and order of the column, padding. This all comes into picture when you come to Postgres performance tuning, right? And obviously, we have to, as a DBA, we have to do a proactive monitoring as well in order to not get any reactive issues. Okay, any P1, P2 issues, right? So we have some set of proactive tuning tasks, which we are going to discuss in this slides. Okay, as discussed, like whenever we build a cluster, we have to define our own DBA standards, and we have to also do some of the proactive tuning tasks like memory parameters, right? So memory parameters, initially when you build a cluster, we are using the PG profile tool to get suggestions, like especially memory parameters that we are going to define. And later point of time, we have a tool called PG bench. This is not an external tool. This is a part of your Oracle binaries. Okay, with the help of PG bench, we can able to do some benchmark tests. Like with help of PG bench, we can estimate the capacity of the database. Like in this particular database, if 100 sessions connects, how many like average response time we will get in different scenarios. If we have 100 connections and it's going to do like 20 transactions at a time with 100 clients or 100 sessions. So how the database average response time looks like, we can just test with the help of this PG bench tool. Okay, so this is very important benchmark tool which comes as a part of your Oracle binaries. You don't need any external extensions for this. Okay. Okay, so now when coming to memory parameters, we have a very important parameters like shared buffers, wall buffers, and effective cache size. And two more important parameters is um, so so related to memories, right? So two more important parameters such like so we have so for each session we have work memory, right? So work memory is also very important. And we also have maintenance work memory. If you do any maintenance like vacuuming, rebuilding the index, clustering. So for these kind of activities, we have maintenance work memory. Okay. So these are the main important parameters that we need to consider. So anyhow, while building the cluster, we are going to define these parameters based on the PG tune. So based on the PG tune tool, right? So it's an open source tool. Most of the people or most of the DBS will use that PG tune for defining your own parameters initially, and later based on the PG benchmark test, we can also define these parameters, these memory parameters. Okay. For example, if you want to tune the shade buffers, okay, first let's for example, if you give your shade buffers 256 MB, and you can just do a benchmark test, how many, for example, 10 connections and 100 transactions you are doing at a time, and you can just monitor what is the response time and transaction per second, how it is giving, and you can change your shade buffer parameters to 500, and you can check. So based on these different values of the shade buffers, we can define which value is the best for your current workloads. Okay. So again, we have to work closely with application team as well. Per second, how many sessions it gonna connect to the database. Okay. That metrics we need to have from the application team, and we can define these parameters based on the PG bench. So basically, what is a PG bench? PG bench is a utility or tool as a part of your Postgres binaries. Okay, when you configure this PG bench, first we need to initialize this PG bench. When you initialize this PG bench, by default, it will create 4 tables in your database. Okay, this is just for testing purpose, right? To do a benchmark test, it will define 4 tables, and it also inserts some data into those 4 tables, like almost 16 MB. By default, it will generate 16 MB of data in the 4 tables. If you want, we can also define, we can also insert more data into these tables, not only 16 MB, even you can insert 2 GB or 10 GB based on your requirement. We can load that much of data into that 4 tables, and you can use this PG bench utility, and you can use -c option for how many clients you are going to connect at a time. And you can use parallel option as well. Parallelly, these many sessions is connecting, and how many transactions you are going to perform on those 4 tables. Like by default, it performs DDL and DML operations both. So when you create this PG bench, automatically it creates a procedure, PL/SQL procedure, and it uses that procedure for doing manipulations of those tables, that 4 tables like DDL, DML, select statement, insert, update, everything. It performs all the statements, and based on the load, based on the current transactions and client, it's gonna give us the best, what is the average response time for these queries. Okay, it's gonna give that information. Okay, even not only shade buffers, we can also tune wall buffers. We can also tune work memory, especially. Work memory is used for every every session. We have work memory, right? So in the work memory, basically it does all sorting and merging operations, right? If you do any sorting and merging, it happens in the work memory for each dedicated session, right? So what you can do, you can just define some, by default 4 MB is the work memory parameter, right? So you can just check how is the average load. And you can also try to sort some data, and you can see whether this is hitting for example, you have defined 4 MB of memory, and you are fetching some 1 GB of data. So you can just generate an execution plan, and you can check whether this query is hitting the memory or hitting the disk. Okay, so based on the execution plan, we can verify whether it is sorting in the memory area or disk area. So these kind of things we can able to define, or we can able to monitor work memory. So work memory is basically at the cluster level we are going to give at one time, but later if any session required a more read operation, you can just allocate allocate this work memory to a specific session, not at entire cluster level. So it's always good that you can define or you can set the work memory parameter at the session level based on your requirement. For example, you are running a bad job every night and you are trying to pull some reports. So at that specific session, you can define the work memory parameter to a bigger value. And anyhow, it is a session level, it's gonna clear once your report is pulled, right? So it's always good practice that you can define work memory to session level based on your requirement. But on average, based on your database workload, you can define a static parameter uh, at the entire cluster level, but later point of time based on your requirement, you can just change at the session level. Even the maintenance work memory as well. For example, you are doing a vacuuming operation for a big table. Okay, the default size of maintenance work memory is 64 MB, right? So if you are doing for a big table or you are doing a index rebuild or you are doing a clustering operation on a very big table, so you can just define this parameter at that particular session level, set maintenance work memory equal to, for example, you are going to do a vacuuming for a big table, you can just define to 1 GP and you can just do a vacuuming operation or rebuilding the index or clustering operation, whatever you want. Okay, you can just change that parameter and you can allocate this value. But again, based on your system resource, based on your system load, you can just define a one average value maintenance work memory, and if required you can just change at the session level. Similarly, like work memory, you can change the maintenance work memory at the session level when you are doing a vacuuming operation or clustering operation or rebuilding operation. Okay, this is about the parameters. Based on this PG bench, we can define all the memory parameters, and based on the PG tool, we can define all these memory parameters. Okay, so this we are going to see practically also how this looks like, all the memory parameters and how the PG bench works. Okay, how we can test the PG bench, benchmark testing, and how we can see the average load test of that particular sessions and particular sequels. Okay, even not only for those particular four tables. So when we initialize the PG bench, it just creates a four tables. Not only for those four tables, you can also do a PG bench for your own tables as well. Okay, for example, you have some test table or employee table. You want to do this PG bench, for example, on that your own table, you can also do that. So this we can see practically how we can do, how we can initialize this PG bench and how we can test the benchmark testing for any table and how we can see the average transactions per second, how this is behaving. Okay, so how it generates the query average response time in the different scenarios. So we'll see that as well. So as a proactive tuning task as a DBA, memory parameters are very important and it plays a major role for your tuning, for stable your environment, right? So that is the reason, like memory parameters we have to first define when we build a new cluster. And then analyze and explain are the two main utilities or commands that we are going to use. Analyze is to gather the stats of your tables. Okay, so by default, anyhow, auto vacuum process will take care of auto analyze and auto vacuum, right? But few times, okay, so few times when your table is very busy, it's gonna skip that analyze as well as your vacuuming process, right? For a busy tables. So at that moment, we have to, as a DBA, we have to monitor the bloating tables. Okay, we're gonna configure a script for monitoring the bloating tables. So we have seen how we can identify the bloating tables in vacuuming classes, right? So we have a very big query that we can just verify the bloating table, how much percentage of bloat it has happened for that table, and we can also verify when is the last uh, analyze happened, okay, with the help of pgstat, user table, or all tables, right? So with the help of that, we can just monitor the bloating tables and when is the last analyze. If it is not happening on that particular table, if it's a very busy table, your vacuuming process is keep on skipping, then we have to, as a DBA, we have to manually do this analyze process, right? And as well as vacuuming. Okay. Anyhow, to fix the bloating tables, we are going to do a full vacuuming, or we also have an online operation called PG repack, right? With the help of these two utilities, we are going to remove the bloat tables. But if your table is very busy and you want a good stats to be gathered, okay, we need analyze to be executed frequently, and we need to monitor. Okay, if that busy table is skipping any analyze or vacuuming process based on the queries. Okay, so this is good that we have to monitor that bloating tables, and if any tables is skipping, and we have to gather this analyze manually as a DBA, because if your optimizer does not have the latest stats, then the execution plan will be changed, and it's not a good plan the optimizer will generate. Okay, so we'll see some different scenarios practically about the analyze and execution plans, and what are the different options available. Okay, in the execution plan, you want only execution plan of the query to generate, or you really need to execute that query and needs to generate a plan, and you as a part of your execution plan, you have to gather the IO details, wall details. Okay, there are so many new features which they added in the execution command, in the explain command. We are going to see that in practically also, how what are the main parameters that we can use while pulling the execution plan, and even analyze as well. So we'll see few scenarios if you don't have the latest stats, how the execution plan behaves. Okay, so we'll see practically different scenarios, and we see about the indexing as well. As we know, index plays a major role in any database, not only Postgres, right? So for good execution plan, or for better execution plan, always index plays a major role. So we have by default in Postgres also we have B tree index. When you create an index, by default it creates as a B tree index, and it also supports different indexes like functional based index. It also supports B tree index. It also supports spatial. There are so many indexes it does also supports. Okay, Postgres, but by default it is a B tree index. Based on your requirement, you have to define which type of index you want. Okay, for most of the workloads, B-tree index is suitable, but for few of the tables and few of the operations, it also requires some different indexes as well, right? And when you create any unique constant or primary key constant, by default, it creates a unique index automatically, right? So this also we'll see practically how we can monitor how we can create the index and how we can monitor the fragmentation of the index. Is there any good extension that we can use for checking the fragmentation of this index? Okay, that also we'll see practically about this indexing. And one more important thing is clustering. Okay, so this feature is not available in Oracle. So there is a concept called clustering in Postgres where you can rewrite the entire table data in proper order in the storage level itself. Okay, basically, if you have a table and your application is continuously writing data into the table, so it's not in proper order, right? Basically, how whatever the order which you insert, it's gonna insert in same order, right? But if you want to fetch the data in a proper order, you use the order by class or any of these functions to get the data in proper order, right? Order by any that column name, or you are going to order in ascending order or descending order, you're gonna define that. Okay, if you want the data in proper order, by using order by class, we gonna use in a select statement. But if you want to segregate the data in proper order at the storage layer itself, okay, you can use the clustering concept. So you create a table, and on the top of that table, you anyhow you are going to create an index, right? And based on that index, we can do the clustering operation. So you can just tell to the table, cluster table name using this index. If you tell at the storage layer, all the data will be segregated in proper order. So even this we'll see practically, but it requires a downtime actually. It requires an exclusive lock on that table when you are doing the clustering operation. But clustering operation can also be performed using PG repack. Okay, we have extension called PG repack where we can do online rebuild of your tables, right, to reduce the fragmentation. It does the same like full vacuuming. Okay, with the help of PG repack, you can also do the clustering operation as well in online, right? So if your application is very critical and your application team is not accepting the downtime for doing the full vacuuming or clustering operation, you can go with PG repack, right? So PG repack, most of the people will use for online redefinition, or they can also do the online clustering operation as well. Okay, so if you do the clustering of the table, it segregate in proper order and it will be very fast, right? So actually why we are creating the index, basically index also have a separate data, whatever the column which you create index, it stores in a proper order, right? And each column have, or each row have a row ID, and it directly go and fetch that particular records when you create an index, right? And if you do clustering on the table, and it will be like very fast because your personal data also storing in proper order in the table. So this also we'll see practically how the clustering works and uh, how the index works. Okay, so these are the two important proactive tuning tasks as a DBA we have to do. And next thing is database design. So we already know about the vacuuming, right? So vacuuming is very important. Because of the MVCC architecture in Postgres, vacuuming plays a major role, right? So we know if you want to reduce the bloating of your table, you have to go with the full vacuuming. Anyhow, auto vacuum process, we have auto vacuum process as well. But if you want to release the space at the storage layer and you want to do a full rebuild, you can go with full vacuuming or PG repack if you want to do an online operation. And we already seen about the padding, right? So padding is some extra space that gonna allocate for your row, okay, or your column based on your data type which you have defined. So data type and the column order also plays a major role while you design the table, right? So basically, as a DBA, whenever you get any deployments, we should not directly go and deploy the tables. First, we're gonna see, and we have to design that table whether this table really required a partitioning or so this table column order also we have to see, right? So this all we have to see while you are deploying the tables. Okay, so padding we already seen how we can check the padding and what is the extra space. So we can just read the metadata of your rows and the page, and we can see, okay, the row length of your record. Okay, so and if you just order of your column, if you just define from higher data type to the lower data type, then definitely your padding will be reduced, and definitely it increases the read operations, right? So this we already seen about the padding. So the table design also plays a major role in terms of proactive tuning tasks in order to avoid the reactive tuning, right? And partitioning finally. So partitioning is very important because it also helps in terms of performance. You are going to divide a table into multiple tables. In Postgres, partition is something different. It's not like Oracle. So in Oracle, what we do, we create a table and we choose one column as a partition key. And based on that partition key, we are going to create multiple partitions, right? Based on that column. You can just define the range partition or list partition, or you are going to define interval partition. So based on your requirement, you are going to define, right? So in Postgres, it's something different. Okay, we have to create partition as a separate partition table, as a separate child table. So this we are going to cover in the next slides, more about the partitioning. Okay, so we'll see how it is different than other databases in Postgres. Now, when coming to reactive tuning, as we know, so there is no inbuilt tuning packs in Postgres. We have to go with some extensions. Most popular extension is PG profile. So PG profile is one of the extension where we can this extension is not part of your contrib modules. We have to externally download this PG profile, and we have to generate the snapshots with with select statements. We can generate the snapshots, and that select statement we can just enable in the cron jobs, and we can generate every 1 hour or something, and so on. Okay, just a second. Yeah. So we'll see practically how we can generate similarly like our AWR report using this PG profile extension, and we'll see how the reports look like. Okay, so it captures everything like similarly like Oracle. It captures the wait events, it captures the vacuuming information, it captures the table space growth, it captures the top SQLs like SQL order by read, gets, SQL order by executions. It generates all kinds of SQLs using the PG profile, similarly like AWR report. Okay, so we'll see how we can generate this AWR report using PG profile extension. And this is very important, right, for any kind of database issues. Okay, we can just have a good baseline report. Based on the baseline report, we can compare a current report if you have any issues. It's very easy for you to bottleneck. And this report, okay, is not part of your Postgres cluster by default. We have to go with external tools. And now we also have few of the main important monitoring catalog views, like PG stat statement is one of the most powerful view, and this will come as a part of your extension. Okay, this PG stat statements, you can just fetch all your historical data, like in Oracle you have um, some all historical views, right? Similarly, like PG stat statements, with the help of this PG stat statements, you can fetch all your historical data. Okay, and we have PG stat activity, which is one of the most important view where we can use for checking the SQL details, which time it has login and what operation it is doing. Okay, we can check the SQL details. Similarly, like $session, we can capture the session ID, and we can capture the SQL text. We can capture what time it has login, what time it has, what operation it is doing. All the details we can capture from PG stat activity. Okay, and PG log, as usual, we can check is there any logs happening. Okay, with the help of PG log, we can just use this two views join operations, and we can identify is there any logging happening in the database, and we can also check at a specific database level. So basically this all parameters is at the cluster level, right? So we also have PG stat database where we can check all the details based on your database level. So if you want to check for a specific database, we can use PG stat database, and we can check what are how many sessions it has connected to this database, and is there any logs on the database. All these things we can use this PG stat database. Very important view. And this we already know, PG stat user table, where we can check all our table related information, right? So you have how many data tuples, you have how many live tuples, when is the last vacuuming operation happened, when is the analyze happen, okay, when is the full vacuum happen, how many inserts you have did, how many updates, how many deletes, everything, all the details of your tables we can capture from this view. Okay, so these are the main important view. We also have the other views, but these are the very important views. So we will provide all the queries, okay, how to monitor the sessions, how to kill a session, and how to check the logs, okay, how to identify the sequence based on the particular timestamp. At this time, what are the queries has been executed from past 5 hours or something based on the PG stat statement. So usually PG profile extension internally use this PG stat statement activity extension only, or views, catalog view, to capture all the uh, reports like AWR report. It uses internally PG stat statement only. Okay, so that is the reason this is very important for even for PG profile as well. Okay, so this we'll see practically also how we can monitor and how we can capture all the details. Okay, now when coming to these parameters we already discussed. Okay, um, parameters are very important for the performance tuning, right? So we can change the parameters at the cluster level or session level or the database level using any shell command or with the help of directly SQL commands, right? And these are the main important parameters that we need to consider for your Postgres cluster. Shared buffers, work memory, maintenance work memory, wall buffers, checkpoint, effective cache size. So shared buffers, we know by default, if you choose the PG tune tool, okay, by default it allocates 25% of your RAM, right? That is which is recommended as per community. Okay, 25% of RAM you have to allocate to shared buffers uh, and work memory. So work memory based on your workloads, based on your benchmark test, okay, you have to define a average value. By default, your work memory is 4 MB, okay, and this 4 MB is not at all, suitable for your normal workloads. You have to increase the work memory, maybe 1 GB or 2 GB based on your workload and how much read operations you are doing, okay, how much data you are trying to process as a part of your batch jobs or your queries. So we have to define this work memory, right? And maintenance work memory as well. By default, it is a 64 MB. We have to define at the session level, both the work memory and maintenance work memory, we can define at the session level. But at the cluster level, we can just give an average value based on our workloads. And if you want to, change, you can also change at the session level based on the operation which you are going to perform. Same maintenance work memory as well. If you are doing any full rebuild, we can just set that the session level and you can perform that vacuuming operation or clustering or indexing operation, whatever you are doing, right? And wall buffers. So wall buffers, as we know, by default, it is a 16 MB, right? So it's keep on generating 16 MB wall buffers until it generates 1 GB of your, 2 GB of your wall segments, right? So for normal workloads, this 16 MB of wall buffers is more than sufficient, but again, you have to do some benchmark test, and if you are getting any weight events on these wall buffers, you have to increase the size of your wall buffers as well based on your weight events, right? So all the parameters, what we are going to define is based on the PG tune, and that parameters are suitable for at the initial stage of your cluster. Later, based on your workloads, we have to increase these all parameters, right? Checkpoint, right? Just checkpoint by default, it occurs every 5 minutes, right? So, and for normal workloads, this 5 minutes is more than sufficient. And if you reduce this checkpoint to a lower value, you have it causes the IO issue as well, right? So for example, you want every 30 seconds or 50 seconds checkpoint to be occurred. So whenever checkpoint occurs, what it does, it has to write the lesson information. It has to write the data from shared buffers to data files, right? All these operations it has to do. And every 5 minutes is a good actually checkpoint, right? And if you increase the more value, for example, every 20 minutes, whenever you stop the cluster, it takes more time, right? All the 20 minutes of data it has to write from memory to disk, and it has to write all the LSN information to the control file. It has to update, and it has to update your wall segment as well, your wall buffers as well, right? So if you increase the bigger value also, it is a problem. So we have to just define average value, which is 5 minutes is more than enough for normal workloads. As per community, we can just leave this checkpoint as a 5 minutes, right? And we have effective cache size, which is we can say aggregate size of your memory. Similarly, like your um, SG, we have aggregate memory, right? SG aggregate memory, uh, which is like it has all the memory components. It has shared buffers, other buffers, wall buffers, okay? So all the physical memory parameter, all physical memory areas, which can be defined with the effective cache size. This effective cache size is the total hard value of your memory, physical memory. It has effective cache size has shared buffers, it has wall buffers, it has other buffers, okay? It has temp buffers. All the buffers will be define with the effective cache size. Effective cache size by default, it as per PG tune tool, it has 80% value of your RAM. Okay, we have to define 80% of 80% of your RAM value to the effective cache size. This is just a soft value. Based on the workloads, it's gonna increase automatically. Okay, effective cache size. So these are the main important parameters that we are going to consider, and we'll see practically each parameter based on the PG bench workloads and based on your clustering operation, based on your select queries, all different scenarios. We can see this practically all these parameters. Okay, so next we're gonna discuss about the partitioning. So how the partition works in Postgres, we'll see. Okay, basically in Postgres, actually up to version 10, there is no real partitioning concept. They are using the inheritance concept. Okay, table inheritance concept. So based on the inheritance concept only, they are going to divide the table into multiple child tables, and they are going to acquire the properties of your parent table to the child table. Okay. Yeah, sorry. So the real partition came from version 10. Okay. And we'll see what are the different types of partition available in Postgres. And whenever you are doing any migration from Oracle to Postgres, this partition are very important, right? So because all the partitions may not support in your Postgres like Oracle, we have very few partitions it supports in Postgres. We'll see what are the partition types which it supports in Postgres and how the partitioning concept looks like. So we'll see. So first, as we discussed, up to version 10, they are using the table inheritance concept, where this table inheritance allow a child table to inherit the properties of your parent table, okay, for all the columns, whatever you have defined. And so based on this inheritance properties, we are treating this as a partitioning, but it's not a real partition. We are just treating like it is a partition kind of things, okay, partition kind of concept. But after version 10, okay, the real partitioning came into picture in Postgres along with the partition pruning. So partition pruning are very important, right? So we'll see what are the how the partition happens in Postgres and what are the partition types it has. And so basically what happens is we have a table and we have a column, for example, timestamp column, and you want to go with the range partition, right? So in Oracle, how you do, you just create a table and that particular column, you just define whether you want a range partition or hash partition, and you just define the ranges, right, on that particular partition. For example, you want to store from 2023 to 24 data, you can just define one partition, P1. And you want 2022 to 23, you define P2 partition. Something like this you define on that particular column. And whenever you insert the data, it's gonna go and fit into a specific partition based on the range of data which you are trying to insert. This is how it works in Oracle. In Postgres, what we have to do is we have to create a table and we have to choose a column for partitioning, right? Similarly like Oracle. And that column we call it as a partition key. Based on the partition key, we have to create a separate tables, okay, not a partition. So here partition is a separate tables in Postgres, not a, it will not fit in the same table. It has to store in a separate table, okay? So it divides into multiple small tables or smaller pieces in Postgres. So we'll see practically also how we can create the partitions and how we can create a separate partition tables. Okay, this is a major difference when compared with Oracle. You have to create the partition as a separate tables, as a child table, or and you have to split this as child tables. Okay, and similarly like Oracle, you will get all the performance benefits like partition pruning and everything. So now you insert the data. So based on the same range, it's gonna go and fit into a specific table, or we can say specific partition table. Okay, so this is how it works in Postgres, and what happens is these are the partition methods that supports in Postgres: range partition, hash partition, and list partition. Only these three partitions will be supported in Postgres. So there is no like interval partition or composite partition like Oracle. We don't have that kind of partitions, right? So if you want interval partition to be supported, interval partition is something that when you insert a data which is outside range of your partitions, it automatically creates a new partition, right, with that specific range in Oracle. That is called interval partition, right? So, but in Postgres, it will not create an automatic partition. It will, because it is a separate table, right? It will not create a separate table automatically. It's gonna fail when you insert the data which is outside of your range. Okay. So for this, if you want that kind of similar functionality, you have to go with extension called PG Partman. So most of the companies, okay, as a part of your migration, when you are doing Oracle to Postgres migration, most of the people will use that. When you have interval partition in Oracle, in Postgres it does not support, so you have to go with PG Part1 extension. So PG Part1 extension is, with the help of that extension, we can manage the partitions very easily, like creating automatic partition, future partitions we can manage, and deleting the old partition based on your retention. Okay, everything we can define in the PG Part1 extension, which is very important, and most of the people will use when you are doing migration activities, especially. Okay, so by default, Postgres inbuilt does not support the interval partition. At this point, we need to remember, and it only supports range, hash, and list partition. If you want similar kind of functionality like Oracle interval partition, we have to go with PG Part1 extension, which is very popular and most used extension to manage your partition. Okay, so not only for interval partition, you can also manage your range partition, hash partition, list partition with the help of PG Part1. Okay, so that we'll see different scenarios in practically also, how we can create a range partition and how we can create a hash partition, list partition. Okay, so as we know, range partition is most suited for your ranges, right? So when you are going to define the ranges based on your timestamp values, okay, on your column, especially your timestamp values based on your ranges for the specific tables, range partition will be best suited. And we have list partition. So list partition is mainly suited if you want to group a specific data. For example, you have a location column, right? You want to store all the location details of US in one partition, and the location of India in one partition, and location of Europe in one partition. So you can just group all the data and store in one specific partition. So for that kind of situations, you can use the list partition, right? So list partition is best suited for that kind of tables, grouping all the data and storing in a specific column based on the list partition which you have defined. Okay, and hash partition. Hash partition is something we are not going to define any ranges, or we are not going to define any locations or something. It is just dividing and storing the data equally. It will distribute the data in all partitions. For example, you have 10 partitions and you have inserted 100 records in the table. It's gonna distribute or divide each partition 10 records, and it distributes the data and stores. This is hash partition. Even hash partition will also support in Postgres. Okay, so these are the only three columns. Sorry, these are the three partitions that going to support in Postgres. So any questions on partitioning? So when we go practically, okay, you will understand better how the partition works. It's not similarly like Oracle syntax. It's definitely you will feel like it's a new concept, okay, partitioning in Postgres. And when you are doing the migration, right? So at that moment, it's very important to understand about the partitioning. And whenever you are designing your database, it's very important that for bigger tables, you can just go and create the partitions, right? So partitions tables, okay? So based on your requirement, you can just define. And we'll also see a few scenarios about the PG part 1. So PG part 1 extension, how we can manage these partitions. So you can just create that extension PG part 1. It is an again external package where we have to configure. It's not part of your config modules. So you can create the extension of PG part 1. When you create the extension, it automatically creates few set of tables and few set of functions. Okay. So with the help of that functions and tables, we are going to define. For example, you have a table T1 and you created a range partition and you have created 3 partitions on that table. Okay, separate partition tables. You can just update. You can just go and update to the PG department that you have a partition table, and if when you update, you have to just define on which column you are going to create the partition tables, and you can just define how many feature partitions you want, and you can also define whether you want a day partition or yearly partition or you want hourly partition. You have to define there, okay, in the PG department. So it will take care of everything. It will create the feature partitions, and you can also define the retention value as well. Okay, if you want to purge, so if you want to purge all the past partitions, okay, you don't want the partition. So basically in Oracle, what we can do, we can just purge the old partitions, right? If you don't want, but here it will deattach that partitions. With the help of PG department, we can just deattach those partitions, and it will take care of deleting the old partitions based on your retention period, which you have mentioned in this partman value, okay, in this table. So we'll see practically so that you will understand better about the PG partman extensions. Okay. So this is about partitioning, and we will also see practically whether it is storing the data into appropriate partitions, and partition pruning is happening. So partition pruning is very important, right? So when you are trying to fetch the data, it should not scan all the partition tables. It has to go and fetch a specific, right? It has to go and fetch the data based on the range which you are trying to retrieve, right? It has to go and select from that particular partition only. It should not scan all the partition tables. So we'll see how the partition pruning also happening in Postgres. Okay. So this is about the theoretical part of the tuning classes. Everything, whatever we discussed, we are going to do. We are going to see practically tomorrow. Okay, starting from this memory parameters, and we'll see how the analyze and explain commands with different options, and we'll see how in clustering and indexing concept. Okay, padding we already seen, and vacuuming we already seen, and we are going to see about the PG bench. Okay, how we can generate the how we can initialize the PG bench and how we can do the benchmark test. This we are going to do practically, and partitioning as well. And we are going to see how we can generate and how we can set up this PG profile extension, and how we can generate similarly like AWR report, how we can do this also we will see. And we also see this static views, okay, this catalog views to capture all the information for reactive tuning, okay, as a DBA. So the few queries also will provide in the lab manual, how we can check the logs, how we can see the active sessions running, okay, and how we can check the wait events of that particular query, and how many sessions connected. Everything we'll provide few of the queries based on these views. Okay, so this all we are going to cover practically along with the partitioning tomorrow. So do you have any questions in theory part? Yeah, if you don't have any questions, probably we can catch up practically tomorrow on this tuning, so tuning concept, okay? Okay, thank you. If we don't have any questions, probably we can catch up tomorrow.
Thank you.